Okay, let's look at problem 7.5. Actually, we're going to look at problem 7.5 and 7.6. We'll do them both. It's just the same setup with the different angles. What we're supposed to do is determine the internal forces at point J. So we're looking right here when the first one, this alpha is equal to 90. So in other words, when the first one is going to be when the force is like this, and the next one, when it's equal to 0, is going to be like this. So first, let's do this one when it's equal to 0. So what are we going to do? Well, we're going to take this little section right here, and we're going to make a free body diagram out of it, right? So we're going to have, here's this little section. At A, I have some AY, some AX. I'm going to cut through it, so I'm going to have an axial force F, a shear force V, and some moment going there. Okay, so these are my unknowns, so I need to figure out AX and AY based on this whole thing. So let's take the sum of my moments. I'm going to do it at A, even though I want A. It just seems a little more intuitive, is equal to 0. So what are we going to have? We're going to have our 500 newtons times 200. And then we're going to have a force here. It's called EX, right? So we're going to, and that's going to be in the opposite direction. So that's EX times 400. So it looks like it's going to be half of it. So EX is equal to 250 newtons in that direction. Okay, so then when I take my sum of my forces in X equals 0, that's going to tell me that AX is equal to 250 also in that direction. So I'm just going to fix this arrow so I don't have to mess with it. I'm going to say AX is there. And then when I do my sum of my forces in Y equals 0, I get AY equals 0. Okay, so that means that this is 0 and this is 250. Okay, so now let's do the problem. So now that was setting it up, so we had the information. Now let's focus on this one. And I'm going to come in here, I'm going to say my sum of my forces in X equals 0. So what does that mean? That means that V is equal to AX, which is equal to 250. Okay, so V is equal to 250 in that direction. Okay. My sum of my forces in Y equals 0 is going to tell me that F is equal to 0, so I have no moment, or so no axial force, fair enough. So my shear force is 250, my axial force is 0, and last thing, let's take my sum of my moments. Where should I take the moments? Well, I can take them wherever I want, right? But because I have these two here, to me it seems easiest to take it here at point J. So I can take it at J equals 0. So what do we have here? We have AX times the distance is 100. And the way I drew this, plus M is equal to 0. So M is equal to 250 newtons times 100 millimeters. So it's 25,000 Newton millimeters. Or I think a more standard way to say it is 25 Newton meters. And that's going to be, sorry, there's a negative on there. So that means it's in the opposite direction. So that's going to be like that. Okay, so there we go. We have 250 newtons to the right, there's 0 axial force, and 25 Newton meters down. Okay, so that's number 5. Now, let's look at number 6, where basically now instead of having this force here, we're going to get rid of that, and we're going to say this 500 Newton force is applied right there. Okay, so the first thing we have to do is redo this stuff, right? Because this is going to now be different. So let's come in here and take my sum of the moments at A is equal to 0. So I'm dealing with the whole rigid, I'm dealing with this whole thing here, right? The whole rigid body, because I'm trying to find EX, AX, and AY. Okay, so in this case, you're going to have 500. Now the lever arm is from here to here, which is times 150. And that's going to make it rotate in this direction. So that's going to still equal to EX times 400. So now EX is going to equal 5/4 of 150, which is, I cheated and wrote this out in advance, 187.5 in that direction. Okay, I don't need to circle this because this isn't really the answer. This is just an intermediate step. So now I'm going to take my sum of my forces in X equals 0. And so that's going to tell me that AX, in this case, is going to be 187.5 in that direction. And my sum of my forces in Y equals 0 is going to tell me that AY is equal to 500 in that direction. Okay, why does that matter? Because we're going to go back over here, this one that we're dealing with. I'm going to redraw it just because I made a mess out of it. I have here, now I have 500 going up. I have 187.5 going that way. I'm cutting off here, so I have my V, my F, and my M. Okay, so now when I take, so this is setting it up. Now let's actually solve this part. Sum of my forces in X equals 0 tells me that V is 187.5 in that direction. Sum of my forces in Y equals 0 tells me that F is 500 in that direction. And lastly, the sum of my moments, we'll still do it about this point right here, about J equals 0. Now this is going to be a little bit different because this 500 passes through there, so it's just going to be 187.5 times that distance, which is 100 still. Now this time it's going to, the moment is in the opposite direction of that, so this is going to equal to the moment. So the moment is 18,700, but I'm going to 18.75 Newton meters in that direction. And that should do it.